TV, where we learn the basic concepts of chemistry. If this video is coming your way for the first time, please do well to like, share, and comment so that it will get to a wider audience. Okay, let us dive straight to the business of the day. We have a question before us here, and this question is based on Brown's law of diffusion. And the question reads: under the same condition of temperature and pressure, hydrogen gas diffuses 4 times as fast as gas X. Calculate the molar mass of gas X, given that the molar mass of hydrogen is equal to 2 grams per mole. And we have the option before us. I'm going to give you just a minute. If anyone can guess the answer, just guess the answer and put it on the comment section. Just a minute before we go into it. So since this question is based on Brown's law of diffusion, let us first state Brown's law of diffusion. Brown's law of diffusion states that at constant temperature and pressure, the rate of diffusion of the gas is inversely proportional to the square root of its density. Or at constant temperature and pressure, the rate of diffusion of the gas is inversely proportional to the square root of its molar mass. Alright, now how can we establish the mathematical expression which you can use to solve this problem? Okay, since Brown's law relates rate of diffusion of the gas and its molar mass, we can solve it in the following way. We take the following solution. So we establish a relationship here. Let us say rate of diffusion of hydrogen gas all over rate of diffusion of gas X is equal to all square roots of molar mass of, okay, since because of the inverse relationship, we expect the molar mass of gas S to be on top and then the molar mass of hydrogen gas to be below because of the inverse relationship. Alright, so now let us see the rate of diffusion of hydrogen gas and also the rate of diffusion of gas X. Okay, gas X. The question says hydrogen gas diffuses 4 times as fast as gas X. This simply means that the rate of diffusion of hydrogen is 4, while that of gas S is 1. Why? Think of a number that when you multiply 4 by that number, then you obtain 4. So that simply means that the rate of diffusion of gas S is 1, and then the rate of diffusion of hydrogen is 4. Okay? So let us go. What should be the molar mass of hydrogen? Molar mass of hydrogen gas we are given, let us say MH2. The molar mass we are given from the equation, which is 2 grams per mole. 2 grams per mole. Then molar mass of gas X, you don't know. That is what you are required to calculate. Okay, we can substitute this into our formula. Okay, so we have that rate of diffusion of hydrogen is equal to 4. That of gas X is equal to 1. Is equal to all square root of molar mass of gas S, you don't know, which is mx. Molar mass of hydrogen is 2, given to you from the equation. Alright, so you all know that from our laws of indices, whenever we have a problem like this, in order for us to do away with this square root, we take the square of both sides of the equation. So we take square of both sides of the equation, 4 over 1, all square is equal to square root of molar mass of gas X all over 2. So we take square of both sides, so that this square cancels this square root. Alright, so what we have next is 4 square all over 1 square is equal to molar mass of gas X all over 2. Alright, this is the same thing as saying 16 all over 1 is equal to molar mass of gas X all over 2. So we can now make molar mass of X subject of formula. We can make molar mass of gas X subject of formula. So let me erase what I have here. So making Ls subject of formula, we are going to have molar mass of X cross multiplying is going to be 16 times 2, all of 1. And of course, 16 times 2 is equal, 16 times 2 all over 1 is the same thing as 32 grams per mole. 32 grams per mole. So the answer is 32 grams per mole, which is option B. So, how many of you were able to get the answer correctly? Okay, if you have any question based on Brown's law calculation, please just put it on the comment section so that we can deal with it in our next video. Thank you and bye for now.